Example 9. The probability density function of a continuous random variable x is defined as follows. So you are given the PDF. For the part A, obtain the cumulative distribution function. So you need to find the CDF from the PDF. So from the PDF to CDF, you need to integrate. You need to integrate every single function that listed here in order to find out the CDF, which is the capital letter of F. So we have been discussed the same example from the previous one, which is the example 8. So the big difference from the previous example to this one, for this example, you are given more than one non-zero function, which is you have 1 and 2 non-zero function. Okay, so before we form the CDF, we do the working for finding the CDF. It's better we write it in this form, in this kind of interval, in order to identify how many interval that we should find out the CDF. So we just denote all the given interval starting from 0 until 1. Okay, from 0 until 1, and followed by 1 until 2. So 1 until 2. So since we have two non-zero function, which is, this is for the 6x over 17, this is for the 6x squared over 17, and 0 for the otherwise. So altogether means that we can notice here, altogether we have 1, 2, 3, and 4 interval that need to find out the CDF. Okay, so we're going to start with the first interval. The first interval is for the x less than 0. So I'm going to write on the interval first, or the 4 interval. I'm just going to write on all the 4 intervals. So from the x less than 0, and then followed by x greater or equal than 0, less than 1, and then followed by x greater or equal than 1, less than 2, and lastly the fourth interval for x greater or equal than 2. Okay, so then we are going to continue with the finding of the CDF. Okay, for the first interval, the capital letter of fx should be equals to integration of negative infinity. It should be from the negative infinity until x, right? It should be a negative infinity until x. So the function that should be right on here should be 0. So integration of 0 function will give you 0. Okay, and then the next column is finding the f of c. F of c is actually the upper limit for that interval. Okay, so since this is the x less than 0, so this is the upper limit, so we are going to find out the f of 0, right? F of 0, so this is the 0. So 0 need to be substituted into this function. So 0 substitute into the 0 function will give you 0. With f of 0 equals to 0. And then we are going to proceed with the second interval. For the second interval, the f of x should be, okay, second interval is starting from 0 until x. Okay, we should start from 0 until x. So since this is cumulative, it should be cumulative from the beginning. So before we start from 0 until x, we should start with f of 0. So f of x is equals to f of 0 plus with 0 until x, with the function 6x over 17tx. Right, so f of 0 we have calculated from the previous part, which is f of 0 equals to 0. Then you just need to integrate for this function. 6x over 17 equals to 6x squared over 2 times with 17, with the limit 0 to x, which is equals to we can cancel out this 3x squared over 17. Right? So we have done for that part, and then we're going to proceed for the f of c. So f of c is f of 1. Why this is 1? Because the upper limit here is 1. So I'm going to find out the f of 1. The maximum here is 1. So substitute 1 into this fx, this function. So substitute, we are going to have 3 times 1 squared over 17. So we will get 3 over 17. Right, then continue with the next interval. Okay, for the third interval, we're going to write it as a f of x equals to, okay, for the third interval, this is the third interval, we are going to integrate from 1 until x, But you have to remember that before we entering this interval, we have accumulate from the beginning. So the accumulation and up to 1 is referring to the f of 1. So we're going to write it here, f of 1 plus with 1 until x, with the integration of the function 6x over 17 dx. So f of 1, we have find out the f of 1 from this part. So we're going to substitute here 3 over 17 plus with the integration of 6x over 17. You will get 6x squared 6x squared. This should be 6x squared. Then this should be 6. Wait, I'm going to erase this. This should be from 1 until x. So then we get 6x cubed over 17 with the limit 1 until x. Right, we are going to solve it. 3 over 17 plus with this integration, so 6, this substitute the limit, so 6x cubed over 17 minus 6 times 1 cubed over 17. So then if we simplify every single things here, I forgot here, this should be 3 here, 3. Right, so at the end, after you simplify, you will get 2x cubed over 17 plus with 1 over 17, or you can rewrite it in the single form, single fraction, which is 2x cubed plus 1 over 17. Okay, so for the last column is the f of c, so it should be f of 2. So f of 2 need to be substituted into this function. 2 needs to be substituted here. So f of 2, it should be equals to 2 times 2 cubed plus 1 over 17. So then you get 1 here. Right, so proceed with the last interval. So the last interval should be f of x equals to f of 2 plus with 2 until x with the 0 function. Okay, we are going to start with the f of 2. So f of 2, since 2 is here, so we're going to integrate 2 until x, but before 2 until x, we already accumulate until f of 2. So f of 2 until integration of 2 until x with the 0 function. So f of 2 we have find out from this part, which is f of 2 is this one, which is equals to 1. So 1 plus with the integration of 0 equals to 0. So you will get 1 for this part. Alright, so we have done for the CDF. And then write down the final answer. You have to write down in piecewise form. So f of x equals to, okay, just copy down all the CDF that we have find out starting from 0 and then followed by this one, followed by this one, and up with 1. Okay, you just copy down all this answer into the piecewise functions. So the final answer should be 0 for the x less than 0, 3x squared over 17 for the x varies from 0 until 1. This is 2x cubed plus 1 over 17 for the x varies from 1 until 2, and lastly 1 for the x greater or equal than 2. Right, so we have done for that part. We are going to proceed. Right, so proceed with B1. The question asks to find the property of x less than 3 over 2. So since the notation already in the form of less than, so we can just straight away write down px less than 3 over 2 equals to the f of 3 over 2. Okay, we are going to use the CDF since we already calculate for the CDF. We have found out the CDF. So you just substitute 3 over 2 into the correct function of CDF. So we have to find out where is the x equals to 3 over 2. So back to the answer here. So 3 over 2 is 1.5. So 1.5, it should be around here. Okay, it should be 1.5, should be around here. This is 3 over 2. So means that we have to substitute the value of x, which is 3 over 2, into this function. Okay, we're going to substitute here. So means here equals to 2 times 3 over 2 squared plus 1 over 17. So that will give you 31 over 68. Right, so then proceed next. Next question asks to find a greater x greater or equal than half. So you have to do something on that before using the CDF function. We need to change a bit. So px greater or equal than half is equals to 1 minus px less than half. So then we are going to use the CDF. So is equals to 1 minus capital letter of f of 1 over 2. So we are going to substitute 1 over 2 into the correct function of CDF. So back to this one. So 1 over 2. 1 over 2 is here. This is 1 over 2, 0.5. So it should be substituted into this function. So then we're going to substitute here. It should be 1 minus 3 times 1 over 2 squared over 17. So equals to 65 over 68. Wait. 65 over 68. Right, so continue. Next. Okay, next is x greater than 3 over 4, less than 4 over 3. So this one you just need to write it in the form of CDF, which is equals to f of 4 over 3 minus with f of 3 over 4. So you just need to substitute 4 over 3 and 3 over 4 into the correct function. So find out where is the 4 over 3. So you just need to okay, check it here. So that 4 over 3 need to be substituted into the second function, and 3 over 4 into the 4 over 3 into the third, 3 over 4 into the second. So you just substitute. So here it should be 2 times 4 over 3 square over 17 minus plus 1. Wait. Should be plus 1 minus with 3 times 3 over 4 squared over 17. So then you get 103 over 432. Right, lastly, lastly, find the median. So the median is, how to find the median? The median is f of m equals to 0.5. Okay, so we have to find out this value where it's cut the total area into half, which is equals to 0.5. Okay, but before that, we have to check out which interval that should be m's located. So I'm going to go back from the previous part. Okay, so let's go through the last column here. The last column here, we have found out the f of 0 equals to 0. So this is, since this is 0, so this interval is not going to be your m's. M is not going to be here because the cumulative here until 0. Alright, and then f of 1, if we calculate f of 1, we get 3 over 17. So 3 over 17 is less than 0.5. It is less than 0.5. We want to find out 0.5. If the cumulative is less than 0.5, then m should not be here. M should not be here because when you substitute the m into this function, you won't get 0.5 because it less than 0.5. The maximum area here is 3 over 17. It is less than 0.5. Right? So means here, means your m, so meaning that your m should be located in this interval. Okay, m should be here since the cumulative here is until 1. So means from 0 until 1, the total area here is just until 3 over 17. Okay, from 1 until 2, the total area is 1. Okay, the total area is 1. So means 0.5 should be here. So this is your m. So after we have found out the location of m, okay, just find out it correctly. So then you can just substitute the m into that function. So we are going to substitute m into this function. Right, so back to this part. Since m should be in between of 1 until 2, so means that f of m should be equals to 2 times m cubed plus 1 over 17 equals to 0.5. Okay, so we're going to solve it. So 2m cubed plus 1 equals to 17 multiplied with 0.5. So the m cubed here should be 17 times 0.5 minus 1 over 2. So that will give you m equals to 1.55. So since this is the only solution for m, okay, and then before that, just to make sure it is in the correct interval, just check whether it is included between the correct range. So since this is in the correct interval, so that's the final answer. So the median here is 1.55.
Example 10. The cumulative distribution function fx of a continuous random variable x is defined as below. So we're given cumulative distribution function fx, and then a, find the values of the constants a, b, and c. It's supposed to be a and b. A and b. Right. So in order to find the constants a and b, when we are given the cumulative distribution function, we just simply make it equal. For example, at x equal to 5, f5 must be equal to f5, which means ax is equal to x over 50 plus b. But then we need to substitute x equal to 5. So we get a 5 equal 5 over 50 plus b. So one of the equation is b equal to 5a minus 1 over 10. So to get the other equation, I'm going to make 10 equals to 10, which means at x equal to 10, f10 equal to f10, which just simply means x over 50 plus b equals to 1. But then substitute x equal to 10. So we have 10 over 50 plus b equal to 1. So we can just simply find the value of b, which is 4 over 5. And then substitute b into the first equation. So we're going to get 5a minus 1 over 10 equals to 4 over 5. So a equals to 9 over 50. So a equals to 9 over 50 and b equals to 4 over 5. B, find the probability density function fx. So I'm going to put it into table. I'm going to write down the interval first. What I meant by interval is this one, this thing here. So x less than 0, 0 less than equal to x less than equal to 5, 5 less than equal to x less than equal to 10, and x greater than equal to 10. And this one is fx that we're going to find. So in order to find the fx from the cumulative distribution function, we need to differentiate the cumulative distribution function. So by differentiate, I mean for the first interval at x less than 0, we need to differentiate 0. From 0 to 5, we need to differentiate ax, which means 9 over 50x, and etc. So I'm going to differentiate everything, every single function. The first one is 0. Differentiating 0 will give us 0. Differentiating 9 over 50x will give us 9 over 50. Differentiating x over 50 plus 4 over 5 will give us 1 over 50. And differentiating 1 will give us 0. And then we're going to write it into the function form. So the first value is 0, but we get 2 0 here, so we're just going to write 0 otherwise. And then the second one is 9 over 50. And it is only valid from 0 to 5. The third one, 1 over 50, and it is valid from 5 to 10. Next, see calculate probability from 3 to 7. So I'm going to use the cumulative distribution function, it's going to be f7, this one, minus with f3. f7 means I'm going to substitute 7 into the cumulative distribution function, but then I need to check 7 lies on which function. So 7 lies here, so I need to substitute 7 in this function. Whereas for the other one, which is 3, so 3 lies here. So I'm going to substitute 3 into this function. So for 7, it's going to be 7 over 50 plus 4 over 5. Whereas for 3, it's going to be 9 over 50 multiplied with 3, which is 2 over 5. Next, D. Find the E2 minus 3x. We need to use the properties of expectation, which simply means we're going to expand it. The property say that E2 equal to 2, E3x, we need to move up 3, so we have 3 multiplied with EX. Thus, we need to find the value for EX and then substitute the value of EX in this equation. So to find the EX, the formula is integrating from negative infinity until infinity x fx dx. This is the formula. So I already put the value of 0, 5 and 10 into the number line, and then I already put up the function accordingly. So I just need to integrate to find the value of EX. So we know that here is negative infinity, here is infinity. So integrate negative infinity until 0, x, multiply with the function, and then integrate 0 until 5, x, multiply with the function, then 5 to 10, x, multiply with the function, and the last one, 10 until infinity, x, multiply to the function, and find the value. Here is going to be 0, here is 0, so integrate x is just x squared over 2, another x squared over 2, substitute the value, so here it's going to be 25 over 2, and another one is 100 over 2 minus 25 over 2, which is equal to 3. So E2 minus 3x, which is 2 minus 3 EX, is equal to 2 minus 3 multiplied by 3, so it's just negative 7. Expectation can be negative, only variant cannot be.